Hi everyone, and welcome to the Measuring Techniques video lecture. Let's get started. No matter what type of sketch that you decide to create, the first order of business is to gather the measurements. In order to create a good crime scene sketch, you must ensure that you have accurate measurements of all the items within the scene, and that includes the evidence, the fixed objects in the scene, and the scene boundaries. Now, there are multiple techniques for gathering measurements, but I'm going to discuss the three most common that are also discussed in your textbook. The choice of measurement technique is up to the investigator's preference and the scene characteristics. Now, triangulation is an easy measurement process that's useful for both indoor and outdoor scenes. All measurements in triangulation are focused on two fixed points in the crime scene, preferably two unmovable points, like door jambs or room corners. The crime scene investigator will measure the distance of each piece of evidence from these two fixed points. Then, using a protractor, you can create where each item is in two-dimensional space by identifying where the lines overlap. You can see this on this slide an example of triangulation using fixed points, A, a door jamb, and B, a room corner. Now, I'll go over an example of this as well. All right, so let's do a quick example of triangulation. Let's say you want to describe your position using the triangulation method. What we're going to do is establish two fixed points that we can measure from. In this example, we have the front door of a house and a flagpole that's outside. What you're going to do is measure from each fixed point straight to your position. The flagpole has a single point to measure from, but you're going to want to document in your notes where specifically you measured from in the door because there are multiple possibilities. In this case, you can see that I measured from the bottom right corner of the door frame. I would document this in my notes so that my measurements are as precise as possible. Now, you may be thinking, well, what about the angle? How do I know where the straight line should go in the final sketch? The point of triangulation is that if you know two fixed points distance, you can use a protractor to determine where the object is without needing to measure any angles. What you're going to do is widen the protractor so that it's the correct distance, properly scaled, from the door to your original position, and then you'll create an arc. This represents the line of possibility from that single point, from the door. Now you're going to do the same thing for the flagpole, once again widening the protractor so that it represents the correctly scaled distance between the flagpole and your original position, and you draw a second arc. Where those two arcs meet is where you were standing originally. Erase those two arcs, and you have the perfect sketch. Rectangular coordinates are another common measurement system that's used for indoor scenes typically that contain a perpendicular set of objects. Usually the easiest is two walls that come together in a corner. In rectangular coordinates, you're going to recreate the XY system that you learned in your high school geometry class. The wall intersection becomes 0, 0. Then you measure from that initial point straight ahead, straight east-west, and straight north-south in order to obtain an X and a Y measurement for the evidence. Since this type of measurement system uses all straight lines, it's one of the easiest to reconstruct in a computer program and only requires you to use a ruler when you're doing it by hand. All right, so let's do an example of that rectangular coordinate system. Just like before, you want to describe your position in a room, and you're going to use the rectangular coordinate system. Now what we're going to do is establish the 0, 0 point on the wall behind you. Excuse me, the wall behind you then becomes our x-axis wall. Next, we pick one of the walls that intersects with our x-axis wall to be our y-axis wall. In keeping with the traditional xy coordinate system and to ensure that all measurements are positive, I'm going to pick the wall to the left of you as the y-axis wall. Now, having done this, the corner behind you and to your left becomes the 0, 0 point, meaning that it's going to be the start of the x-axis and the start of the y-axis. Now, what I've done is I've put in coordinates for all the other corners as well, just to help trigger that geometry information stored in your brain. But if that gets too busy, just kind of ignore all that. All you care about is that 0, 0 point. To measure where you're sitting at in this room, you would draw an imaginary straight line from your current position to the x-axis wall. You want this wall to connect with the wall at a 90-degree angle. So notice I went straight down. You would then create a line going from that point to the start to your 0, 0 corner. That's going to be your X distance. And then to measure your Y distance, you measure from the start of that imaginary line to your current position. That's your Y distance. Now that you have both of those measurements created, you can identify where you're sitting in the room using an XY coordinate description, which looks like this. So what that's telling me is I'm to the left because it's positive, and I'm to the north because it's positive this amount. The last system is called the baseline method, and the baseline method is really similar to rectangular coordinates, but it creates an XY coordinate system between two fixed points instead of a corner. Now, baseline method is great for measurements in outdoor scenes because all you need to do is create a line down the middle of the scene and then measure from it. In this image, the baseline is attached to a specific fixed point of the scene, oftentimes a tree, the edge of a building, something that's not movable, and then it continues in a direct straight line directly east. You can also put a baseline between two fixed objects because that can create a line that does not line up directly with a compass point, so you can do tree 1, tree 2. Once you have your line down, you do the same XY process as the rectangular coordinate system, marking how far down the baseline the evidence is, which is your X, and how far above or below it is, which is your Y. Below would be negative. Since you can make the baseline as big as you need, these can be used for really big scenes. However, you do need to keep in mind that you will need a physical line present for this type of measurement system. So you can't do this in areas in which a normal measuring device like a roller tape would fit, and you also have to have two measuring devices on hand. So what you would do is you would lay out your baseline on the scene, and then you would use a second measuring technique to measure from the evidence to your actual baseline. Now you can also put a baseline down between two fixed objects, like I said, and that allows you to create a line that does not line up directly with a compass grid. In this scene, for example, two trees are used as the fixed points. As you can see, the baseline method can be really useful for large, more spread out scenes. All right, well that completes this measurement technique lecture. So thanks for watching, everyone.